In this hands-on tutorial, we're going to focus on Godot's UI system. We're going to see how to create reusable UI widgets that work really as individual components. You can mix and match in your games, reuse across games. So we're going to see a little bit of code, for example, how to automatically update the bar and a label based on a value change in our bar class, and how to integrate that in your game. And we're more importantly going to look at Godot's layout options for UI design. It's a workflow that was added in Godot 3.0 release. So this is available in text format in the official docs. I wrote the initial tutorial. Now, Godot's UI system has been improved. So even though the original version is valid, this is an improved demo that's open source as well that you can explore if you prefer to learn hands-on with that. When you're working on game UI, you don't want it to be fully responsive, unlike a web page. The game will have a base resolution and a base ratio that serves as a baseline for all devices. You won't want to support both portrait and landscape orientation in general. So that's why you don't need a UI that will adapt to every screen type. You just want it to be scalable so that it adapts to slightly different screen ratios, which is what you have between all the different computer and TV displays and even Android devices. So roughly from 4/3 to a 2:1 ratio, something along those lines. That's why my UI here, it can adapt to the screen size, but we only have the widgets in the top right corner that move and stick to the top right corner of their container, the GUI container. It's easier to understand if I hide the background. Imagine that this box is my game's size. Regardless of my game's size, I have the same margins on the left, top, and right edges of the screen, and the GUI elements are only sliding along with their container. If I was to resize from the left, you'll see it's the bars that move this time. So the game's resolution serves as a baseline, and the viewport will scale based on the device's ratio. Then, based on your project settings in the display category, and the stretch mode and aspect mode actually will define how the game viewport or the camera stretches, expands, contracts, how you map your game being rendered to the different devices. So if you use the expand value on the aspect ratio property, it's going to take your game's base resolution, and if the target screen is a little larger, well, the camera will become a little larger and show a little more of the game world, and then the UI will resize to fit that new screen ratio. If I hide the background and characters, your camera will do this. If the screen is narrower, it will contract a little bit, and if the screen is wider, it will become wider. As usual, the project is on GitHub. It's open source. You can find the start folder inside of the project to follow along with this video, recreate the UI elements as I make them in front of you, and get more insights on how the UI system works. Here is our start project. We're going to have a quick look at the project's architecture. So you only have sprites in there. There are no scenes, everything we're going to create from scratch. Now, you do have an interface folder that will contain the base assets for the bars. You will find life bar and energy bar subfolders with the corresponding specific assets. For the counter, there's a background sprite called label BG that's going to be common to the rupees and bombs containers. And you have some reference sprites you can use, put on the screen to scale your label background according to what the artist wanted you to do. And we have a theme folder because we're going to use Godot's theme feature. It's a little more advanced than just making the UI element, but with this, we're going to create a reusable theme so that all UI elements in our game use the same base default font, and we just have to change the font in one place for all of our interface to update. So themes are extremely powerful. They power the entire Godot editor, for example. Next, you have the characters and background that are, again, just sprites. And with that, let's get started creating our UI. Let's start by creating a UI-based container. For that, we'll open the level mockup. You want to select the game node, press Ctrl A to add a node, and we'll add a control node. It's just to indicate that this is our interface. So I'll name it so, interface, put it around the top of the node tree. Then we'll use the layout menu to modify the anchors on our UI container and to resize it as well. So that's what these options do in the layout menu. And you have the anchors only submenu if you only want to change relative to which parts of the screen your UI will resize and move. Now, make sure in the view menu that you have the helpers visible. The helpers will show you this little anchor widget. The interactive version doesn't work too well right now, but it will update properly when you use the layout menu. So we're going to click and select full rectangle. Full rectangle means rescale and change the anchors so that you anchor to the corners, the boundaries of your parent. If there is no parent control node, this parent will be the entire screen here, as you can see. It means that the interface will always scale to fit the entire game screen, whether it gets a little wider or a little narrower based on the device. We're going to save this interface as a separate scene straight away. So for that, you right-click on it and select Save the branch as scene. It allows you to separate it from the current scene and save it as part of your project. Let's go to the interface folder and save it there as interface.tscn. Now you can click the Open in Editor button to open the scene separately from your main one. So now we are only focusing on the interface. We don't have to watch and care about our level, characters, and all that stuff in our scene tree. In this project, the scene tree is very simple, obviously, but if you're working on a real game, this is a big advantage. And if you're working as part of a team, it will be common for you to work in separate scenes and then merge them using GitHub or another version control system. Let's start by creating the simplest UI element. For that, we'll create a new scene, and we're going to start with the base node for our component. This will be the counter, rupee and bomb counter. We're going to use the background of the counter as our container. For that, we're going to add a 9-patch rectangle node. This one takes a texture as an input, and it's going to keep the aspect of the corners of the texture. It's going to tile the top, bottom, left, and right edges horizontally and vertically, respectively. And then it will tile the texture in the center or stretch it based on the option that you choose. Let's head to the interface folder, counter subfolder, and we have our label background here that we're going to plug into the texture slot of our counter. So I'll zoom in on the texture, and normally if I resize it, you can see that it scales with the widget at the moment. So we want to set the patch margin so that it uses the label's corners and the edges appropriately. For the left and top, we're going to use 8 pixels. Right and bottom, same thing here. And now it should scale a little better. So I'm really zoomed in, so it's a little pixelated and hard to see because of the color, but now it will stretch the texture a bit less. Let's rename our 9-patch rect as counter, save the scene. We're going to save it in the interface counter and save it as counter.tscn. Any special type of counter like rupees or bomb counters will inherit from that and extend it. We're going to add 2 things in our counter. We need a label and a sprite. So I'm going to drag and drop my bomb counter reference to use as a reference. And I will rescale the base counter down a little bit so that it fits this bomb counter. Then I'm going to add my bomb icon to this and the label, but as control nodes, because only the green nodes will scale along with their parent, maintain margins, etc. You cannot use sprites directly. Instead of sprites, you use the texture rectangle node. This is similar, but it has some more options as it can tile, and it will follow the anchors, edges relative to its parent. So we're going to add our bomb icon. We'll click and drag the icon into our texture slot and call it icon. It can be any icon in our case. We will use the layout menu and anchor it in the center right of its parent. you can see all 4 anchors snap to the middle of the right edge of our counter container. And with this, we can remove our bomb template. Now we'll also add a label in there. So select the counter, press Ctrl A, label. Labels are basic nodes to add text. And we're going to do the same thing, layout, but this time we're going to select center left. Let's add a number as a reference for our text. And we will also align it centered horizontally inside its bounding box. And the V-align will center vertically. Now we can now scale our label. You can press the Alt key to scale uniformly in a given axis, and you can scale it to the right as well to see your label stay centered inside its container. If you want to align its baseline with the bomb, there are a few ways to do that, but the simplest way is to add some margin at the top, and you do that by scaling it from the top. Note that scaling for UI nodes doesn't work exactly like scaling sprites. It's only going to resize the bounding rectangle, and it's not going to scale the pixels directly. Our label has one problem. It doesn't look really sexy, does it? So that's where we're going to add our UI theme. We'll start defining it. I'll expand the inspector a little bit. We're going to go down to the theme section of our control. We'll create a new theme inside of it. Now, this theme, by default, is saved inside of the scene. We don't want that, and you can save any resource as part of your project using this little save button at the top of the inspector while you are viewing a resource. Let's click that and select Save As. We're going to save it in our interface folder, theme subfolder, and we'll call it our default theme for the game. Now let's look at how it works a little bit. So you can see the theme bottom docker opened and shows you how the interface will display when you plug this theme into control node. So the text is a little small, and right now it uses the default colors from Godot's editor. The colors we're not too interested in. We only want to work on the label and the fonts for now. So the theme will override the properties that we decide to add to it. And to add property slots that we can override in the inspector, you click the Edit Theme menu, and you can add class items. It's going to add the corresponding slots or properties for the base class or control node type that you select. Let's click that. We're going to click the 2 dots next to the type and select the label class. Add all the properties. And now, inside of your theme in the inspector, you can expand the label category, and you will find all the properties for that. So you have the font subcategory, in which we can override the font specifically for all labels in our theme and in our game. You also have a default font as the base for your theme, and that's what we'll use. So now, if I modify the font color, it won't update instantly in my viewport, but if you look at the label inside the theme bottom panel, see now it's red. So that's where you can preview all the changes you make to your theme resource. We're going to leave that folded for now, and we're going to define a default font for our theme. So let's create a new dynamic font. It's going to be stored inside the theme resource automatically. Note that we can always save it as a separate file, and that's what we're going to do. We're going to save it in the font folder, and we'll call it default font. The point of saving it as part of your file system is that you can then access the font directly anytime and modify this, and it will update automatically inside the theme and on everything that has this font applied in your project. So you can use it on specific nodes without having to plug your entire theme inside of them. Now, in my dynamic font, I want to go to the font category, and we'll drag and drop the Comforta bold font from the font folder. So you can do that. You will see the label update. So now it's quite small because of font size. Set font size to 30, let's say. And now it's a lot bigger already. Be sure to use filter as well. It makes a small difference, but you'll see that with the scaling option on your game, based on the screen size, it's going to look very ugly if you don't have the filter on. So in general, you want that on for fonts. Note that you can also use that to modify the baseline of your font, push it a bit to the top. So you can override these settings here and make sure that your font is aligned however you want it to be inside of your widget. Right now, I'm going to use a lower value, maybe 16 pixels, maybe something like that for this widget. And we have our base counter widget. It's not our bomb counter yet. So now we're going to create that. Select scene, new inherited scene, and you're going to select the parent. So we're going to create a new scene that extends this parent and just changes a few properties specific to our bomb and rupees counter. Let's open this base scene. We'll rename it instantly to bombs counter to start with. And we will save at this point inside the bomb subfolder. So save that. At this point, we can move our bomb icon a little bit to center it exactly how we want it to be. Note that the anchor doesn't move. It's only the sprite that moves relative to it, or the texture rectangle, so that when we resize the bomb counter, the icon will stay anchored to the right side. So our bomb counter will not resize vertically, although it could, but the important part is look at how it preserves the right margin because of how the anchor is placed, while the label stays stuck to the left side. Next, we'll create the rupee counter, so scene, new inherited scene, and we're going to select the counter as a base again. And this time, you want to select the icon. We're going to head to the rupees folder and drag and drop our rupees texture on top of it. Note that we only override this property from the icon node, and that any change we make to the counter base scene will propagate to both the bomb counter and the rupee counter. Let's rename the base node rupee counter, then save the scene inside the rupees subfolder. As we name the node properly, Godot gives us the right name in the scene tree. Now we can, again, move the rupee icon exactly where we want it to be, give it the margin it should have relative to its anchor, save. And there's one problem with the label. When we modified it a little bit, it moved relative to its parent. So let's head back to the counter base scene, and we're going to fix that. I want to reset it using the layout menu to anchor to the center left of its parent. And now I need to modify the font again. So I'm going to head back to my default font resource. I'm going to double click it to open it in the inspector and reset the bottom extra spacing to 0 so it centers properly. Maybe I want to push it down a little bit, so I'm going to add to the top value 6 pixels and then save. Now if we head back to the bomb counter and rupee counter scenes, you will see our label is not perfect just yet. The reason is that as we modified these scenes a little bit, Godot considers that we've modified the node's margins, and so we've overridden properties from the counter. We want to reset these properties, so select the label, head down to the margin section in the inspector, and click the reset value button next to the margin properties that have been changed. Your label's bounding box will resize to fit that of the counter. We have to do the same for the rupee counter. Although we can do it manually here, we're going to do it differently. Select the label, click the properties like toolbox icon in the top right of the inspector, copy parameters, then go to the rupee counter and paste the parameters. We'll reset the margin to follow that of the bomb counter scene. Now you can save both scenes and you have your bomb counter and rupee counter working. For example, if I was to resize the base counter a lot like that, you should see your bomb counter and rupee counter update instantly. You will get that for all properties that you did not override from the parent scene. So that's the big strength of working with inherited scenes in Godot. Now I'll resize, save again to have a decent size, and get my good old rupee and bomb counters again. Let's now work on the bars, and we're going to start with a base bar. So we can close the counters, go to scene, new scene. And if I head to the final version of the game and open the base bar, you will see that the top parent is an HBox container node. This node is going to take its children and it will position and resize them based on a few properties. It will line them up horizontally. So if I were to reorder the nodes as part of the container, they swap position, and the container will respect the minimum size of each of its UI elements. So let's create our bar. The first node we'll add will be an HBox container, and we'll rename it bar. This will be our base bar scene that the other types of bar, the special ones, will inherit from. Then, as a child of it, we're going to add a texture progress. So this is a spatial node that allows us to plug in our own textures to create progress bars of all kinds, loading bars, but also live bars, etc., whether they are horizontal, vertical. Let's expand the textures category of it. We're going to head to the bar folder and live bar subfolder of our project, drag and drop the background into the under slot. You will see that the node automatically resizes to show the entire texture, and then drag and drop the fill.png onto the progress slot. You're not going to see any change there because by default, if we head to the range section of our inspector, the min and max values are set for us, but the actual value, the current progress of the bar, is set to 0 by default. You can set it to something other than 0 to see your texture fill a little bit. Then we want to add something that resembles our counter a little bit. It's not exactly like our counter scene. We can still reuse the nodes to save time. So right click on the bar, and one way to add nodes from a scene and customize them is to select the merge from scene option. Enter the file system by clicking the two dot buttons, head to the interface, counter, and double click counter.tscn to open it. We're going to import from the root node, from the counter, and Godot will take all of its children along with it. So click OK. You will see the counter gets added after our bar. We can place it before that to have it on the left. Now, if we resize our counter, it doesn't push the live bar node. That's because the parent, the container, is using the minimum size parameter of the counter. So let's head to the control section, rectangle category, and set the min size to something like 160 pixels. You can see the size property updates along with it. We want to swap our icon and our label here. We want to plug in the label HP in there. So let's go back up to the texture slot, drag and drop the HP texture on top of it. And we're going to use the layout menu to snap it to the center left of its parent, of the counter node. Then you can alt-click on the vertical handles of the bounding box to resize the node uniformly and center it vertically on its parent. You can also resize it down on the x-axis because the texture sets the size of the node. Now to add some margin between our HP element and the left edge of its parent, we just have to move it. This will automatically update the margin of the control node. So you can keep the shift key down and press the right arrow to add a 10 pixels gap between the left edge and the HP element. Or you can press W to select the move tool, then click and drag with the shift key down to constrain to the left axis and place your HP label wherever you want. Now the HP is anchored on the right place, but you can see that the label is still anchored to the left side of its parent. So we're going to select it, go to the layout menu, and anchor it in the center right of its parent. Then there are two ways to place the text. You could use the center property of the label so that the text is always centered inside the container, and the container's size defines where the text is going to end up. Or you can contract the text and use some margin from the right side of the counter node. Then align the text to the right on the horizontal axis by changing its align property. And make sure to expand the bounding box a little bit, because when you change the text inside of it, it pushes the bounds to the right. So we don't want that to happen, but we do want to align our text to the right side of the node. And you can check the clip text property so that when you add too much text inside of the label, it will clip on the right and it won't push the boundaries towards the right side like that. I can show you without clip text on. We're going to add a long string of text. You will see that the container expands to the right, but if you keep the clip text property on, you can add as many characters as you want, and it will prevent the box from resizing beyond the size of its container. Now we want a format similar to, for example, 12 HP out of 40 for our text, and we're good with that as a template. So you can save the bar. We're going to create the life bar and the energy bar. So go to scene, new inherited scene, and inherit from the base bar one. We're going to rename it life bar, and you can save it inside your life bar folder directly. We don't have anything to change here. Then for the energy bar, do the same scene, new inherited scene, use bar.tscn as a base. We're going to rename it energy bar, and then we have a few more properties to change. Let's save it inside the energy bar folder. We're going to head to that energy bar folder, and then we have to change the background and fill sprites on the texture progress node. So let's select it. Go to the top in the texture category. We want to replace the under texture and the progress texture as well with the fill. The bar is smaller than its container. But as I said, Godot will use the textures as a baseline to define minimum size of the gauge. So normally, the bounding box should fit that of the bar. I can resize it down to the bar and no further. If I were to change the order of the nodes, the container expands again. As we are using a container as the parent, the container also sets the minimum size of its children. We need to resize the energy bar container itself instead of resizing its child. Select the energy bar node and contract its container as much as you can. Then select the HP label. We want to replace it with the EP label. You'll see that the texture on a texture rect appears in the top left corner of the bounds by default. Can change that with the stretch mode property. So click on it and select keep centered to center the sprite inside its container. Then you can select the text because we want it to be a bit smaller as the label itself is a little smaller. To do that, we're going to create a new font. Let's head down to our theme. One thing we can do is move it and add a new theme. There's something a little simpler for the label. We can use override using the custom property categories. We're going to expand custom font. For this one, we can head to our font folder. We're going to use our default font, but create a new one from it. So right click on it. You can duplicate the resource and give it a new name. You could call it EP label, for example. EP label resource we want to move to our energy bar folder as it should only be used by that bar. So click and drag it there. That these resources are not the font, so they are very lightweight based resources, right? So it's not a problem to have many of them in your project. Click and drag the EP label resource on the custom font slot. By default, it doesn't activate the property, so you want to click the checkbox to activate it. Nothing changes because for now, it's a duplicate of our default font. So let's go inside of it. We're going to change the size down to something a bit smaller, like 24, for example. You can already see the font looks a little better. And set the top property so that it aligns a little better with our EP label here. With this, I want to modify the minimum size of the counter, so I want to override that from the parent, make it a bit smaller, like 130 pixels. You may also want to resize the EP texture horizontally so that it respects the margin that we set on its parent scene and that it aligns with the HP bar. Same thing, you can resize the label container here so that it centers properly vertically. With that, our bars are done. All right, so now we have our base UI components. We're going to head back to our interface scene. If you've closed it, you can press Ctrl-Shift-O and look for interface. It's the last one, interface.tscn. And we're going to drag and drop our various scenes inside of it. So energy bar, as I'm in the folder here, I'm going to head to the life bar and drag and drop it as well. I want to get my two counters on top of that. So bomb counters and rupee counters. Then we're going to use containers again to arrange these elements together. So we need the two bars to stack vertically. Let me get the counters out of the way. So we're going to use a vertical box container or VBox container for that. This is the vertical equivalent of the HBox container we used for each of the bars. So create that. We're going to put it at the top of the hierarchy and call it bars. Then the energy bar and life bar will drag and drop inside of it. This uses the tree order to set the visual order, the elements in the UI. So you want to set the life bar to be above the energy bar. You can use a shortcut for that. Click on the node to select it and Control up to modify its position in the hierarchy. Then for the bombs and rupee counter, we'll use an HBox container again, horizontal box container, and put the bombs and rupee inside of it, call it counter, and we're straight going to go to the layout menu and put it in the top right corner of our interface. You can already see a little problem. The bomb counters and rupee counters are really collapsed here. And that is because our counter scene doesn't have a minimum size. So when you get this problem, which can be common when you design UIs at first, it's because you haven't set a minimum size yet. And then the parent container uses the smallest possible size for these widgets. So let's open the bomb counter scene and then from it open its parent, the counter scene. And on the counter, we'll set a minimum width. The minimum width will be something like 120 pixels. In the counter scene, it doesn't change anything, but if we save and go back to our interface, you will see nothing changes because Godot considers that we have overridden the minimum size on our two nodes. So click one of the nodes, head to the rectangle category under the control section, and click the reset value next to the minimum size. You want to do the same for the rupee counter. And from there, your counters will still be anchored in the top right corner of the screen. So you want to reuse the layout menu again, because resizing the nodes pushed the containers bounding box to the right. So re-click the top right corner, align, and there you go. Your counters are properly placed on the screen. So from there, with one of the containers selected, you can start to move them using the Shift key and pressing the down and left arrow in this case to add some margin around the edges of the screen. I'm going to move the bar a few times this way, so I'll use the same amount on the left edge and on the right edge of the screen, 40 pixels roughly. And now when you do that on nodes, on the y-axis in particular, if you want to center the two widgets, you will need a different margin on the counter container than on the life bars. And with that, our interface is set to anchor to the full rectangle of its parent. And even though we don't have a node for it here, there is always a viewport node at the very top of the hierarchy. So it is always the parent of your interface if you don't have any other parent in the scene. That's why this full rect option sets the node to use the entire viewport. But if the screen was to expand, we can simulate that by clicking and dragging on the handle of our interface. You can see that the nodes still anchor to the right corner. So save here, go back to your level mockup, and you can click and drag the interface scene on top of the game, and magically it will place perfectly on top of your game. The scene system in Godot makes it very easy for members of your team to focus on a specific part of the game, and then you can just click and drag the node, drag a reference to the node inside of your main level scene, and whenever they update, the source scene will update in your level and the rest of your game. So congratulations and thank you kindly for getting there. In the next part, we will do a little bit of programming. We'll see how to add some values at the top of our widgets that we can funnel down to multiple sub-elements like our number label and our texture progress, so that when we change the life of the player, we change it in one place and it updates in multiple parts of our interface. Don't forget to check out the Godot course if you haven't already. I'm working on very high quality tutorial. It's already in early access since a little while. That said, thank you kindly for watching. Be creative, have fun, and see you in the next one. Bye-bye.